So I'd like to do this example using kind of that symmetry, center of mass frame approach. Maybe I'll write the steps afterwards in case you like that approach. If you prefer to use the formulas, which probably most people, and usually I like plugging into formulas because it's simple. So, if I have the formulas, I'll probably do that. If I don't, and I don't want to look them up, maybe I'd do this, right? But anyways, I'm going to show that as a process, how you can kind of use symmetry and center of mass frame to do this particular problem. Let me first kind of draw a picture of it. So we have a 200 gram mass. You might notice these examples all kind of resemble each other. It says one ball rolls to the right at 4 meters per second and has a mass of 200 grams, right? So maybe I'm not that imaginative when it comes to coming up with different numbers and examples, I guess. But now the second ball, though, is also 200 grams. And it is initially at rest, so there is no speed there. So the way I would look at this is I would say, okay, so M1 equals 200 grams, right? M2 equals 200 grams. That might make some parts of the formulas we looked at kind of easy, especially when you subtract those two. That's going to go to 0, right? But this means that V1 naught is equal to 4 meters per second, and V2 naught is equal to basically 0. Okay. So to do the center of mass kind of way of looking at things, the first step you have to do is to find the center of mass velocity based on the information that's given, which means I'm going to take a weighted average 200. Maybe I don't need the grams there. We'll get rid of it. 200 times the 4 meters per second plus 200 times the second one's velocity, but that one is 0, so that's just going to turn out to be 0, so I'm going to ignore it. Divided by the total mass of 400. Okay, that's basically doing center of mass formula there, neglecting the second term because it was 0. So let me see. 200 over 400 is like 1/2. I think that's just 2 meters per second. Again, right? So that means we have, maybe I can add to my picture here and say, okay, this is the center of mass point, and it has a rightward velocity of 2 meters per second. But now I'm going to translate this into center of mass frame. So that's kind of the second step. So first step, again, was find VCM. And I'm writing this here in case you like this method. You can copy down the steps into your notes and maybe try doing some of the problems with them if you like. Second step is, like I said, I'm going to write down now what I think the initial velocities are in the center of mass frame. And the basic, last time I kind of looked at the picture and figured that out, maybe by visualizing things, but the basic process is you take each of these initial velocities here and you subtract VCM from them, right? So that means that, and the way I'm going to notate that, the standard notation for a physicist is to put a prime for the center of mass frame, which kind of represents a moving frame. So that's the notation I'm going to use. So in other words, V1 naught prime is really the center of mass frame, initial velocity of object 1. Boy, that was a mouthful. But that winds up being 2 meters per second because it's 4 minus 2. V2 naught prime is going to be equal to minus 2 meters per second. You might notice that since both of them have a mass of 200 grams, this is very symmetric looking, right? So again, this step was basically, subtract VCM to get the new initial velocity. So I'll just put in V prime 1 naught and V prime 2 naught was what I did. Okay, so that was step 2. Step 3 is I'm going to exploit the symmetry, which is basically say, you know what, in this very symmetric looking center of mass frame, these two things just bounce off of each other, which means that the final velocity, I meant to say, I accidentally wrote the naught there. V1 prime is the final velocity, not with the 0, right? Should be equal to minus 2 meters per second. V2 prime will be equal to positive 2 meters per second. So basically, this is like, basically it's switch signs on everything. Switch signs for getting V1 prime and v2 prime, which is basically the final velocities in center of mass frame. And now what I need to do to find the final velocities in the regular old frame, the frame that we've been watching this thing from since the beginning, we need to add back the center of mass velocity. So that's going to give me 0 here, right? Because 2 plus minus 2 is 0. And for v2, I'm going to get, it looks like 4 meters per second. So basically now it's this last step is add VCM, right? Second step was subtract VCM. Fourth step is add VCM, and in between you switch, right? But this is to get the final results of V1 and V2. Let's go ahead and check if that actually worked right there. So it says first ball at rest. I think that is in alignment with my answer of 0 for V1. And second ball is 4 meters per second to the right, which is what I also got.